Bismillahirrahmanirrahim. Assalamu alaikum. My name is Sadaf Iqbal. Welcome back to Programming Fundamentals and Introduction to Computer Programming. Today's lecture number 4, and the topic is functions in C. We have discussed many topics, subtopics in this function in C. We will see more subtopics related to functions in this lecture. Okay, today's lecture outline. We have discussed in previous lecture about functions called by value. We have discussed it in details with examples. And in today's lectures, we will discuss functions called by reference, which is the second method of calling a function. And we will see examples of how we call a function by calling by reference. Secondly, we will see the difference between call by value and call by reference. And then we will discuss passing arguments to function and the return values from function. And depending upon these two things, we will see how the function, user-defined function, is categorized in 4 different categories. Then we will discuss one of the type in this lecture, that is no arguments passed and no return value. Okay, coming towards a function called by reference. First of all, we can recall what are actual and formal parameters. We have discussed these two things in detail in the previous lecture, but just to recall them, what are actual and formal parameters? The term parameters refer to any declaration within the parentheses following the function name in a function declaration or definition. Whatever the parameter list is, we define in the function definition and in function declaration, they are actually your parameters, or we call them formal parameters. And the term argument refers to any expression within the parentheses of a function call. When we are calling a function, that list of arguments, we call it arguments, they are actually your actual parameters. So function declaration and function definition, they are your parameters inside the function declaration and definition, and they are known as formal parameters. And during function call, the values you pass, they are your arguments, and they are your actual parameters. So coming towards pass by reference, both actual and formal parameters refer to same location. So if you recall your pass by value, we have discussed in the previous lecture that in pass by value, both actual and formal parameters, they are in different locations. So in contrast, in pass by reference, actual and formal parameters, they are actually in the same memory location. So this is the difference. And change made inside the function are actually reflected in actual parameters of caller. So whatever you are doing to those parameters in your function definition, they will actually reflect the values of your actual parameter. You can see in the coming examples, it will be more clear to you. Okay, when we call a function, remember, this is an important point, when we call a function by passing the addresses of actual parameters, then this way of calling the function is known as call by reference. In pass by value, when we call a function, we passes the values of actual parameter. But in pass by reference, the difference is when we call a function, we will pass the addresses. Remember, we are passing the addresses of actual parameters, but not the values or the variables. We are not passing the values or variables. We are passing the addresses when we are calling a function. So this way of calling the function is known as call by reference. The operation performed on formal parameters affects the value of actual parameters. As discussed in the start of this slide, that both actual and formal parameters, they are in the same location. So whatever the task is performed on the formal parameters, it will reflect or it will affect the value of your actual parameters, because both actual and formal parameters, they are in the same location, memory location. So in order to pass the addresses, when we are calling a function, we are passing the addresses. So in order to pass the addresses, we need some special variables, and those special variables that can hold address of the variable, and they are known as pointers. Those special variables are called pointers. So what are pointers? At this stage, this knowledge is enough that pointers actually, oh, the slide is hidden, the line is hidden. Okay, I can just, pointers are those variables that can hold the addresses of some other variable, right? So pointers are those variables that actually hold addresses of other variables. We will discuss pointers in more details in coming lectures. That is a separate topic, pointers. At this stage, this knowledge is enough that pointers holds the address of other variables. Okay. So coming towards example of function call by reference. Okay. Suppose we have two variables, x is 10 and y is 10, and they are integer type. When we call a function, here there's a function that the name of the function is fun, and the return type is integer. Okay, coming towards the function call. So you can see that we are not writing, when we are calling a function, we are not writing x and y. We are not passing the variables, or we are not writing 10 or 20. We are not passing the variables or not the values. We are passing and x and y. We know that and represent address in C language. So and operator x and operator y, that means and this and x is the address of x, and y is the address of y. So you can see in the boxes, the value of x is 10 and the address, suppose it is 100. Value of y is 20, which is declared over here, and the address of y is 201. So what we are passing when we are calling a function, we are passing address of x. So address of x, that is 100, is actually passed by calling a function. That is actually called by reference. So we are not passing the values, but we are passing the addresses. So this thing is passed over here where the function is defined. This is the function definition. Integer pointer ptr1 and integer pointer ptr2. Okay, the ptr1 will carry the address of x, as the address of x is passed. So what will ptr will have? It will have the address of x 100, but not the value, remember. And here ptr2, it will contain the address of y, as we have passed and y operate and y when we have called the function. So ptr2 will have 201, not 20. I hope it is clear. So now what is happening inside the function? As we have discussed that whatever will happen to your formal parameter will affect the value of your actual parameter. Remember, in call by reference, whatever you do task on your function formal parameters, right, you are actually affecting the value of your actual parameters. So what we are doing here, pointer ptr1 is equals to 20 and pointer ptr2 is equals to 20. What actually we are doing? Let us see the next slide, you will get more clear idea. So pointer 1 is equals to 20. What does that mean? It means that your ptr1 is holding 100. When you write static, it will access the value of that address. So it will access the value of that address, which is 10, and then convert it into 20. So 10 is converted into 20. I will repeat it again. The ptr1 holds the address of x, which is 100, right? So static, when we write static, When we write static, what does static mean? Static is known as reference operator. By writing static in front of ptr1 variable and ptr2, we are accessing value of that particular address, right? So ptr1 means that we are static ptr1 star. This is for pointer. We are accessing the value of that address which is inside ptr. So we are accessing the value of that address. The address is 100 and the value of that address inside that address is 10. So we are converting this 10 to 20. So it will be converted to 20. Similarly, ptr2 is equal to 10. What we are doing, we are accessing that value 201 and converting this value into 10. So here the value of x will be 20 and the value of y will be 10. So coming back towards that program, so when the brackets ends, the curly bracket ends, the control will go back to the function where it was called, right? So if we want to print over here, if we want to print this line, like I want to print the value of x and y after calling the function, what will be the output? The output will be x have become 20 now and y have become 10. So I hope it is clear that whatever we are doing with the values in formal parameters, it is affecting the values of actual parameters x and y because they are in both are in the same location. And we are here when we are calling the function, we are passing addresses instead of values. So this is actually function call by reference. Let us see some other examples. Okay, to use call by reference, we need to do two things. Pass the addresses of the actual argument instead of passing values to the function. Okay, and declare the formal arguments of the function as pointer variable of an appropriate type. So we have to use pointer variables in order to uh, use those variables, right? To store the addresses of those variables. Okay, coming towards another example, function call by reference. What is going on in this example? There's a function known as increment, and here the variable is pointer var. Although we are performing the increment on variable var, however, the variable is a pointer that holds the address of variable num. Okay, let us see first. Let us see the main program. This is the main program. What happens in over here? We have an integer num variable with the value 20. So this way of calling the function is known as call by reference. Instead of passing the variable num, we are passing the address of variable. So what we are doing here, we are calling the function, and we are not just passing num, we are passing and num. That means we are passing the address of num variable. Wherever that num variable is present in the memory location, we are passing that address. Okay, and when when the compiler reaches this line, the control will go back to where the function is defined, that is over here. And here what we are doing with this variable, we are actually incrementing it with +1, right? We are increasing it with +1. So we are using static variable is equal to static variable +1. So what will be the output? After these brackets, the control will come back over here and it will print value of num is num. So output will be, as we have discussed, that although we are performing the increment on variable var, however, the variable is a pointer that holds the address of variable num, which means the increment is actually done on the address where value of num is stored. So your answer should be num is equals to, the value of num is 21. So let us run this program in code block and see whether it is 21 or something. This is the same program. Okay, let us run and compile. Why it is taking time? Okay, so your output is value of num is 21. I hope it is clear. Okay, coming back towards the slides. So coming towards next example, that is increment the number by 1. I think they are almost the same. Okay, let us see. This is the function declaration, and we have a main program. We have two values, x is equal to 10 and y is 20. Okay, we have printed this x and y before calling the function. Right? We have written initial value of x, initial value of y, calling the function. Okay, we have a function name try to change. We are calling this function and we are passing address of x and address of y. ठीक है? Okay, यहाँ से जब हमारा function call होगा, the function will give control will be forwarded to where the function is defined. Here we have the function definition. We have pointer x and pointer y, which are holding the address of x and y, remember. And what we are doing, we are incrementing pointer x with plus plus and incrementing pointer y with plus y plus plus, right? So when we will print this function, okay, we will print the value of x inside function and value of y inside function. What will be the value of x and y? And after this, the control will go back over here. It is printing the same values as these two, because it is final value of x and final value of y. Let us see what will be the value of x and y before and after calling the function. So the expected output should be x and y should be the same before calling the function, that is x is 10 and y is 20, and after calling the function both should be incremented by 1, that is x should be 11 and y should be 21. And yes, this is the expected output. So you can do whatever you want to do inside the function, just pass the addresses of the functions, addresses of the variable, sorry, instead of the values, if you want to use function call by reference. So here is example number 3, function call by reference, swapping numbers. We did the same example with function call by value, if you remember, in the previous lecture. So what is happening over here? We have main function, two variables, number 1, number 2, 35 with 45 values. So we are printing before swapping, number 1 value is num1 and number 2 is num2. Okay? We are printing it before swapping. Then we are calling the function and passing the addresses of num1 and num2. This is how we call a function by reference. So what is happening? These two addresses will be passed to function definition and stored in some pointers. So variable 1 pointer and variable 2 pointer, they will be holding the addresses of num2 and num1, right? And then we will perform the swapping. Now remember, we are performing the swapping on the pointers, not on the variables, right? So the swap happened on the addresses of the variable num1 and num2. It is performed on the addresses. So this is the same technique, the way we swap two numbers. We have an integer temp number, store the value 1 over here, value 2, and this is the way how we swap two numbers. So what will be the output? After this, the control will come back where the function was called, and then we have printed after swapping num1 and num2. Let us see what will be the output of this program. Yes, this is the same program. Swapping numbers, function called by reference. So before swapping, the number 1 is 35, number 2 value is 45, and after swapping, number 1 value is 45 and number 2 value is 35. I hope it is clear. The value of the variable have been changed after calling swap number function, and the swapping is happened on the addresses of the variable, right? Okay, example number 4. This is a simple example. What is this? This is your main function. We have simple one value, and this is a function. We are passing the address of x, and the control go back to the function where it is defined. We are saving the address of x in pointer ptr, and here we are changing the value to 30. So when the control come back, here we are printing it, the value should be 30, right? So the function fun expects a pointer ptr to integer or an address of an integer. It modifies the value at the address ptr. The dereference operator is used to access the value of at an address. In the statement static ptr is 20 value at address ptr is changed to 30. The address operator and is used to get the address of variable of any data type. In the function call statement, fun and x, the address of x is passed. So these are the same points we have discussed earlier. So nothing is new. I hope it is clear how we uh, call a function by reference and hence how we call a function by value, right? So coming towards difference between call by value and call by reference. Call by value, this method copy original value into the function as an argument, right? Let us, okay, first we read it, then I'll give same examples to recall the call by value and call by reference. So this method copy original value. We are passing original values, original variables, right? Copies of original values. Change made to parameters inside the function had no effect on the arguments. Whatever we are doing to formal parameters will not change the actual parameters, because both formal and actual parameters, they are in different memory location, right? So call by reference totally different. In here we are not passing the copy original values, we are passing the addresses of the arguments, and whatever you change made in formal parameters will actually affect your actual parameters, because both are in the same memory location, right? So as we have seen this example in which the value of x was 20 and we have passed the address and it is changed to 30. Let us see, this was called by reference. What we are doing, we are passing and x, that is we are passing address of x. So here the value, you can see after calling the function has changed the actual parameters. So now the value of x, which is the actual parameter, has changed to x is equals to 30. This is call by reference. Now let us see the call by value. In call by value, you can see here we have a function x, and x is equals to 20, and when the control go back to the function where it is defined, x is equals to 30. We have made x is equals to 30, but when we will run this program, you will see. Let me close this first. Let us run this program. You will see that the value of x will remain 20. There is no effect on the actual parameters, as we have changed the value of x formal parameter, but it will not affect the actual parameter, because here we are just passing the value. We are not passing the addresses, we are just passing the value, and it has that didn't affect the value of your actual parameter, because both the formal and actual parameters are in different locations. Okay. Okay, coming back to slides. I hope now this call by value and call by reference is clear to you. Coming towards next slide, that is passing arguments to a function. Arguments are the values specified with the function call, for which the formal parameters are declared while defining the function. Okay, when we call a function, when we define a function, there may be arguments or there may be no arguments. So function can be with arguments and function can be without arguments, right? So with arguments, declare and define with parameter list and values of parameter passed during call. You can see here, when we declare it, we will write integer x, integer y, whatever their type is, we will write in the brackets. And when we call the function with arguments, we will pass some values when we are calling the function. And function without arguments, there will be no parameters included while defining or declaring the function, and no values passed during the function call. You can see error declaration, there is nothing inside the brackets, so there are no arguments. And when you are calling a function, you will not pass any value. With arguments, you can see here we have a function definition. Here we have integer x and integer y. So we have arguments, two arguments. So when we will call a function, we will pass two values, two variables. So they will be reflected over here. So x will be 2 and y will be here 4. And at the end, the control will come back to the function call. There is another thing, that is returning a value from a function. So returning a value. A function may or may not return a result. Function, in previous slide we have discussed, a function may have an arguments or it could be without arguments. And now we will discuss the return type. The function may or may not have a return result, but if it does, we must use the return statement to output the result. So if it is returning a value, we have to declare it in the function definition and declaration, right? So return statement also ends the function execution. Whenever the return statement occurs, your function will be, execution will be end. So hence it must be the last statement of any function. If you write any statement after the return statement, it won't be executed, because compiler will consider it and then the control will go back to the function where it was called. The data type of the value returned using the return statement should be same as the return type mentioned at function declaration and definition. So that the return type should be same. If you have written integer type, if it is returning some integer value, then both declaration and definition, in definition you have to write int. They should be same. If it is, they are not same, then the error will, the compilation error will. So look at this. If we have, in this example, we have integer, that means it is returning some value. And you can see when we are calling a function, we are storing that value in some variable. So this is the function definition. It is returning a into b. That could be result or just or an expression. So the control will go back to where the function was called, and the value returned by the function must be stored in a variable. So it is storing the variable result in the result. So we have discussed these returning a value from function and arguments, passing arguments to a function. So depending upon these two, the user-defined functions are divided into 4 categories. And they are functions with no arguments passed and no return value. The second is functions with no argument passed but a return value. Functions with argument passed but no return value. And the fourth one is functions, where function with argument passed and the return value. So depending upon these two things, we have divided the user defined functions into four categories, and we will discuss these with examples in the coming slide. So in this lecture, we will just discuss the first one, that is function with no arguments passed and no return value, right? So here you can see this is the syntax of your function call. This is syntax for function call, that is return type, function name, argument, and these are the four possibilities. You can see void function. Void means nothing is returned. So the return type, return value is no, and we can see there is nothing inside the bracket. So arguments, no, there is no arguments. Integer function and brackets. So there are no arguments, but the return type is integer, so it is returning some value. So yes, return value is yes. Similarly, void function integer, nothing is returned, but there is an argument. And in the last one, integer function, integer, it has both the arguments and it is returning a value. So coming towards the first category, that is no arguments passed and no return value. So used to display information, or they are completely dependent on user inputs. When a function has no arguments, it does not receive any data from calling a function. Of course, we are not passing any value when we are calling a function, and we are not getting back any value from the function, right? As there are no arguments and no return type. As it does not return a value, the calling function does not receive. So we are not passing any arguments and we are not receiving either, because there are no arguments and no return type. So the syntax you can see is void function bracket. Void means nothing is returning back, and we have zero arguments. So when we will call a function, we will just write the name of the function and the brackets, right? This is how we will call a function, and in function definition, we will have void function and simple brackets and whatever statements you want to execute. So coming towards an example, just add two numbers with no arguments and no return type. So this is your function declaration. You can see void addition, simple brackets. This is the main function. This is the addition. This is where we are calling the function. Here we are calling the function. We are not storing anything because we are not getting back anything. We are not passing any value because there is no argument. So coming the control, go back to the function where it is defined. Here what we are doing, we have two variables a and b, and we are finding sum of a and b. Sum is storing in the sum. Sum is equal to a plus b, and we are printing the result inside this function. So sum is the sum of a and b is sum. So when the bracket close, the control will go back over here and just print the next line if there is any line. Let us run this program. Okay, you can see the flow. Control passing, when we call the function, control passes to where the function, okay. We have no arguments, we have no return value, and control comes back to where the function was called, right? Let us see this example in, okay, this is the same example. Simply, it will add and print this statement. You can see sum of a and b is 30, and these dots are the line which was, just to tell you the control, it will come back to the where the function was called, and it will print the next line, right? So this example was with no arguments and no return type. Okay, let us see another example. Okay. The next example is check whether the integer entered by the user is a prime number or not. Okay. We have four categories, and we will I will try that we will do the same examples in all the four categories, that we will get the same output but with different user defined functions. So in first we have no arguments and no return type. We will use the same examples, the three examples in the coming next categories as well. Okay. So this is a program, no argument passed with no return type, and we are checking whether the number entered is a prime number or not. So we have made a program. This is a program check prime number. This is the main program, and here we are calling calling this function with no values passed because we have no arguments and no return type, right? So what will happen, we will go to the where the function is defined. Here you can see we are using void with no arguments. Whatever we are doing in the program where the function is defined. This is the simple way to find the whether the number is prime number or not. We have declared two n and I and flag, which is initially 0. We will you will enter a number. There's a loop, and it will take the remainder. If it is 0, of course the flag will be that will be not a prime number, so the flag will be declared 1. And here it checks that. So it is this is actually interrupting it. Anyhow, we will see in the code block as well. So if the flag is 1, so it will print. If the flag is 1, it is not a prime number. Else printf, it is a prime number. So explanation. The check prime number function takes input from the user, checks whether it is a prime number or not, and display it on the screen. ये जो भी display होगा ये हमारे function definition में ही हमने इसको display कर दिया. The empty parentheses in checkpoint number statement inside the main function indicate that no argument is passed. So you can see here no arguments are passed, and white there is no return type. So if we see this example in code block, you can see when the flag is 1, that means the remainder was 0. If the flag is 1, so it is not a prime number, and else it is a prime number. So let us check this program. So you can make any program from any of these four categories. You can use any category with no argument or return type, or arguments with return type. So, and let us enter 7. So 7 is a prime number, right? So we have made a program, but we didn't use any arguments, and we have a no return type. Okay, let us see another example, the last example in fact. And this example takes two numbers and as input from user and display which is a greater number. So this is a declaration function declaration, void as no return type, and simple brackets, nothing inside, has no arguments. Here we are calling this program, not passing anything, and here's the main program function definition. You can see in no arguments and no return type, your main program is inside your function definition. So you are actually printing everything in your function definition. It is not necessary, but you can see major code is inside the function definition. Here we have two numbers. We will enter two numbers and compare if I is greater than j, the greater number is I, and else the greater number is j. So let us run this program on code block. This is the same program. Let us run it. So let us enter any number, 23 and 65. So the greater number is 65. I hope this is clear. We will discuss the other three categories with the same examples in the next lecture. Thank you so much.